This question, the ropes A, B, and CAD can support a maximum tension of 600 newtons, and we know that the angle theta is being given to us as 40 degrees. So we have to determine the largest mass at C that can be supported without exceeding the allowable tension, and the angle alpha as well for the equilibrium. Let's say the tension T with which we are pulling is T over here. So that this will definitely be T over here, and this will have some other value. Let's call it this as T1, this is T1, and this as T2. Right, so if this is an equilibrium, so first off, C will definitely have an mg over here, and since everything is in equilibrium, so we should be having T1 same as mg. Let's call it equation number one. Okay. And since the pulley is also in equilibrium, so now we need to make the components of the forces about the pulley. So if we want to make the components of this tension force, let me just make the components. So since this is theta, this is going to be T1 cos, T1 sine of theta, and this component along T1 is going to be T1 cos of theta. So why am I adding both? Because they are in the same direction. And likewise, there will be a component of T, there will be components of T2 as well, like T2 cos of alpha, because this is also alpha as per the alternate angles, and hence this is sine of alpha. And the pulley is, I think it's not given over here, so that the pulley has a mass or something, so I think it is massless. So all we have to do now is equate the vertical forces as well as the horizontal forces. The vertical forces are these two, so if we equate them up, we will have T2 cos alpha is equal to T1 plus T1 cos of theta. Right. And we know the value of T1 already. T1 should be equal to mg. So replacing T1 by mg. So mg plus mg cos of theta. We know the value of theta as well. So that's, I think, 40 degrees. 40 degrees. So this will be mg plus mg cos of 40 degrees. Okay. So the value of T2 cos alpha from here I'm getting as mg times 1 plus cos of 40 degrees. Let's call it equation number one. And if we equate the horizontal forces, then T1 sine of theta should be equal to T1 should be equal to T2 sine of alpha. This force and this force are equal, which means that T1, this is sine of alpha. So this is T1, which is mg. So mg sine of theta, theta is 40 degrees, should be equal to T2 sine of alpha. So if we flip the equation, then we have T2 sine of alpha should be equal to mg sine of 40 degrees over here. Okay. Now it's given that the maximum tension can be 600 only in both the cases. So if we make T1 as 600, if we make T1 as 600, which means that over here it is 600, uh, then T2 will automatically be more than 600, right? Because if you notice carefully, 1 plus cosine of something is a number which is greater than 1. And a greater than 1 over, I mean, if I want to explain it, let me just do a little bit of manipulation with this particular equation. Can I write this as T2 is equal to mg? And mg is nothing but T1. So for the moment, let me write it as T1. T1 plus cos of 40 over cos of alpha. Now, if T1 is 600 and 1 plus cos 40 is a number which is greater than 1, and it is divided by cos alpha, which is a number less than 1. So greater than 1 over less than 1 is a number which is greater than 1, and greater than 1 times 600 will come out to be greater than 600, which means that T2 will break. I mean, the other rope will break, right? It cannot afford to have any tension more than 600. So with this analysis, we can definitely say that greater than T1. So we cannot really afford to make T1 as 600 because T2 will come out more than 600. What we can do is we can make T2 as 600 Newton. So by default, T1 will come out to be less than 600, which is okay. It should be less than 600. It cannot be less than or equal to 600. It cannot be more than 600. So from this, we conclude that T2 should be equal to 600 over here. Uh, if T2 should be equal to 600, then what do we have to find, by the way? Uh, we need to find the largest mass C and the value of alpha as well. So we need to find the value of M and alpha. We are not interested in the value of T2 anyway. So from equation 1 and equation 2, we can actually divide, these two equations to get the value of alpha over here. So equation 2 over equation 1. So T2 and T2 will be cancelled. We are left with sine over cos, which is tan alpha, and mg sine of 40 over mg 1 plus cos of 40. So fortunately, the m and m is also cancelled. So we are getting the value of alpha right away from here. Let me just bring my calculator. So that's sine 40 times 9.8 over 1 plus cos 40, 1 plus cos 40. In fact, there's an mg. G is also getting cancelled, so I just missed that. G is also getting cancelled. So it's as simple as sine of 40 over 1 plus cos of 40 as well. And the tan inverse of this value comes out to be 26.22 degrees. That is the value of alpha. And now we can easily find the value of m. How is that? Because we can use any of the equation. Let's say we use equation number 2. From equation 2, we know that T2 is 600. We just reduced that. So this means that 600 cos of alpha, which is 26.22, should be equal to mg times 1 plus cos of 40 degrees, right? So this value comes out as 600 cos of 26.22 over dividing by g times 1 plus cos of 40. That will give me the value of m, that is the maximum mass. So the mass comes out as, let me just grab my calculator again. So cos of this value times 600 over 9.8 over 1 plus cos of 40. So this value comes out as 31.10 kilograms. So that is the final answer. Thank you.